welcome to Commodore History Part 5, where we're going to be talking about the Commodore 128. Also, welcome back to special guest Bill Hurd.
Hi, Bill Hurd. I'm the designer of the Commodore 128, and it's good to be back here with the 8-bit guy.
If you've watched the series so far, you'll know that Commodore had released a new computer design about every 2 years or so, each one being more successful than the last, until 1984 when they came out with the Plus 4, which was a market failure. Commodore needed another computer in their portfolio soon.
But Trammell is gone now, not only gone, but heading up the forces of competitor Atari. And with personal computer sales leveling off, the pressure is on Commodore to come up with something new.
So they introduced the Commodore 128 in 1985. Let's take a look at the box. It appears the two main things the marketing department wanted to tell us is that it's expandable to 512K and that it's compatible with the Commodore 64. Okay, let's see what we get inside the box. There's a very hefty system guide, but at least it is spiral bound, making it easy to read while working on the computer. And this is, I believe, the first time a Commodore computer was shipped with floppy disks. Inside, you get a tutorial disk, and then a boot disk for CPM mode. Looking in the little cubby over here, you still get one of these antenna switch boxes, since they still figured a large number of people would be using these on readily available televisions instead of dedicated computer monitors. And you get a little bit beefier power supply, and while the voltages are the same, they did change the connector on the end, since the C128 requires more amps. Now, let's have a look at the computer itself. The design was remarkably different from the existing breadband C64 that they had been selling up to that point, keeping in mind that the 64C would not be introduced until 2 years later in 1987. While the C64 had an appearance that looked like something that might have been designed in the late 1970s, the 128 definitely had the look of the 1980s with its beige color, slim profile, and sharp lines. But what is the story behind this computer?
So you might wonder, why the heck did Commodore make a Commodore 128? In some ways it seems so out of place, right? Well, I was actually working on the LCD machine originally. Jack Trammell had already left. Their management was light. Middle management, the big management was missing. The middle management were breeding like sheep, but nobody figured out to stop us. So I laid down a design literally on that 0.1 inch graph paper, and Fred and I took off with it. So basically the answer is because nobody was there to stop us. We felt like we were filling a hole, and we thought that we could build upon the Commodore 64 name and base and user base and get some mileage out of that.
Obviously, the 128 was meant to be an improvement over the C64, so what were some of the new features? Well, on the outside, it has all of the exact same ports on the side and the rear as the Commodore 64, but it does have an addition of an RGBI video port, which we'll talk about later. And much like the Plus 4, it also has a proper reset switch on the side. On the keyboard, it has an extra row of keys. All of these keys here are the same ones present on the C64, and the 128 adds in the numeric keypad and all of these keys up here. Most of these keys don't do much of anything noteworthy and were mostly designed to be used by whatever software developers wanted to use them for. However, the 4080 key is a locking key and serves only one purpose. It sets the default boot screen to be either 40 or 80 columns, and once the computer is actually started, it has no effect. These cursor keys are essentially redundant to these cursor keys down here, but despite having a key for each direction, they aren't actually any easier to use. The layout is awkward, much like the cursor keys on the Apple IIc, only worse because they're located high on the keyboard, making them uncomfortable to use. So that's the outside. What makes it better on the inside? The motherboard of the C128 looks quite a bit more complex than the C64, so let's see if we can break down some of the differences. First of all, there's 128K of RAM, which is twice what the C64 had, and where the computer got its name from. And also on the motherboard here, we have a standard 6581 SID chip for sound, which is identical to what came in the C64. And there are two input-output controllers, just like on the C64, only they're on opposite ends of the board this time. And here's where things start to get interesting. There are two CPUs. That's right, two of them. The first one here is an 8580, which is basically just a newer version of the CPU that was already used in the C64. However, it was capable of running at twice the speed. And next to it is a Z80 CPU. This is the same CPU that was used in countless computers of the era, starting with really early home computers like the Altair, but also used in pretty much any computer that could run CPM, such as the Osborne. It was also used in the whole TRS-80 line of computers, but also in less powerful home computers like the Sinclair ZX81, and even in the Spectrum and the Mattel Aquarius. It was also used in every MSX computer, and believe it or not, a variant was also used in the Nintendo Game Boy. And this just scratches the surface. The Z80 was quite a popular CPU. So why does it have this extra CPU? Well, it turns out there was an issue with the CPM cartridge that was available for the C64.
Well, guess what? The CPM cartridge didn't always work also. We didn't understand what the cartridge's problem was till we implemented our own Z80 on the board, and then we found it one day. To be 64 compatible, I had a problem, and I had a power supply problem, because with my switching supply, I didn't want to make it an amp and a half bigger and charge everybody. I mean, pennies count in quantities of a million. I couldn't make the supply bigger for the occasional CPM cartridge. But if I put the Z80 into the board, I think it was 100 mil. It turns out then that the Z80 saved my tail end. When the guys from Commodore Texas showed up, they brought with them their Magic Voice cartridge, and it didn't work on the 128. You know, it would try and assert itself right when the 6502 reset. It didn't know about the MMU and all this stuff, and so it'd crash. So what we did, and we did this overnight, we fixed every major problem overnight. So the Z80 would wake up, he'd look and go, there's that game chip out there. There's that Magic Voice cartridge. And he would set up the C64 mode all himself, and then he'd jump to the reset vector, and Magic Voice worked. So the Z80 went from being kind of a pariah to, oh, damn glad I had that in there. And actually, when you hold down the Commodore key, you're talking to the Z80, to boot C64 mode and stuff.
This chip here is the Vic II, which was a newer revision of the video chip used in the C64. The video aspect itself is virtually identical, but there are some differences in the chip itself. The regular Vic II chip in the C64 was a 40-pin package, but the one in the C128 was 48 pins. So why the extra pins? Well, believe it or not, these 3 pins here were used for the keyboard. These extra keys on the C128 meant the keyboard matrix needed a few extra pins to be able to detect these, and since there were no free I/O pins on the existing chips, they thought it would be cheaper to just add these to an existing chip on the computer rather than adding another I/O chip onto the board. This pin here runs the clock for the Z80 processor, and this pin here has to do with 2 MHz mode for the computer. But the Vic II was not the only video chip in the computer. Right next to it is another chip called the VDC. Now this is an entirely separate video chip that's used for 80-column display. And here's where things get really weird. So there's this regular round video port on the back, which is identical to the one on the C64. However, remember that RGBI port I mentioned earlier? Well, that's where this comes into play. You see, the Vic II chip drives the regular composite display, and the VDC outputs only to this RGBI port, which means if you wanted to view the 80-column display, you'd need an RGBI monitor, just like the ones used on IBM CGA computers. And since the computer has 2 video outputs for 2 entirely separate monitors, you can't actually run dual monitors on the computer and have 2 simultaneous displays. Little to no software ever made use of this, however. And because it uses an RGBI signal, it's considerably sharper than the video coming out of the composite display. However, every rule and everything you know about the video capabilities of the C64 do not apply when using this display. For one thing, the memory layout is totally different. While the VIC chip shares memory with the CPU, just like on the C64, the VDC, on the other hand, has its own 16K of dedicated video memory. Now, this has a few pros and cons. On the bright side, that means that when using this chip, you have access to all 128K on the motherboard, freeing up RAM. But the disadvantage is that access to the video RAM is much slower. In fact, the way that the CPU communicates with the VDC is very strange.
That thing was a nightmare. It turns out to have been the only chip that was already being worked on, and it was being worked on for the Z8000. And Bob Ola came to me with the engineer responsible for the 80-column chip, and he said, "Can you use this instead of what you were going to use?" Now I was using a 6848, 6548. We had a version 2. But it's the industry standard, and I was going to give it multiple bit planes and make color and stuff. And I looked at the guy. We like using our own chips. We are so much in control. We can do good things making our own chips, usually. And so I had one question, which is this a superset of the 6845? And he answered yes. And I should have asked, do you know what that question means? So I made an error. I remember those 3 seconds I made that error. I bought into a chip thinking I knew what it could do, and it turns out it didn't. It did things like it would only transfer 256 characters at a time. Well, that's 2.5 rows of 80 column. What good's that? It turns out it didn't have an interrupt when you're done. And when I figured out, like, well, the 6845's got an interrupt, why don't you? I asked the designer, he said, well, you can simply look at a register, and that'll tell you that it's now time to, do another 256 byte transfer. And from then on, we had this running joke where nobody would wait for the phone to ring. We just kept all checking our phones whenever this guy was around. And finally asked, what's with that? And we said, we always could just check the phone to see if there's an inbound phone call. So the 80-column chip was pretty much a mess. As we got to CES show in 2 weeks away, the final rev of the chip comes, and it had been broken. I can't even tell you all the different ways it was broken. At one point, I had to ground out this little tab here to the ground pin, which was 48, I think. They had tried to slip in something called a back bias generator, and it was new. It was supposed to save power, and it slowed the chip down even worse, and we lost our first column of display. And when I grounded this out, I'm grounding out the substrate that the chip's made on, and the first column came back.
So let's talk about the capabilities of the 80-column chip. So its primary purpose was to be able to output 80 columns of text at 25 lines, essentially double that of the C64, and it could produce 16 colors. And for this purpose, it did a pretty good job. But what about graphics capabilities? Well, it also had a bitmap mode, and you could do 640 by 200 pixels. However, there was a problem here. You see, that resolution requires 16K of RAM. So there's no RAM left over for any color information. So with a stock C128, your choices were essentially 16 color text or monochrome graphics.
But the chip itself was actually capable of addressing up to 64K of RAM.
So eventually some of the tech-savvy owners started to desolder the RAM chips and replace them with higher capacity chips, giving it 64K of video RAM. In fact, even today you can buy aftermarket products like this one, which is designed to make the job easy by just putting this daughter card in. No soldering is necessary. Then with this, color was possible using color cells, much like on the C64. However, the cells were much smaller at 8 by 2 pixels, which was a good thing. However, it does not support any sort of multicolor mode, so there are strictly 2 colors per cell, and it does not support sprites. So with these capabilities combined with the slow access time for reads and writes, this chip was essentially useless for video games.
It's not that the 80-column chip couldn't be used for games, it's just that there was no particularly good reason to do so, being that the 40-column chip was much better suited for it. And also not everybody would have access to an RGBI monitor. Speaking of monitors,
Commodore also made the perfect monitors for use on the C128, such as this 1084. It has connections for composite video or the separated LCA video, and RGBI for use with 80 columns. And they added a button on the front that would allow you to switch between composite and RGBI modes, so you could easily get access to your 80 column applications with just a single monitor. To enable the 2 MHz mode, you can type fast at the command prompt. However, if you do this in 40 column mode, the screen goes blank because the video chip cannot operate at this speed. Typing slow will bring it back to 1 MHz mode. The only use here would be as if your program had some calculations to do that didn't require the screen, it could go into fast mode while doing them, and then return to slow mode for the result. However, if you use the 80 column mode, it works fine and you get twice the speed. So just as an example, you can see how fast this program is operating, and then when fast mode is invoked, you should be able to see a significant difference in speed.
of course, the benefits of the C128 didn't end at just the enhanced hardware.
They also included a much better BASIC. Much of the enhanced graphics and sound commands from the Plus 4 made their way into the C128's BASIC version 7, so it was possible to use BASIC to write games or other applications that use graphics without needing to know how to use poke commands to control the chips directly. In fact, the demo disk that shipped with the C128 was actually written in BASIC to show off the command set and give people a brief overview of how to use the new graphics commands. The new commands even allowed for creating and controlling sprites, and while the demo isn't particularly impressive from a hardware standpoint, it was certainly impressive for having been written in BASIC. In fact, it was possible to do entire works of art by just using a series of line, draw, circle, and fill commands such as this code here, which draws Bart Simpson on the screen. The C128 also included new disk drive commands, also borrowed from the Plus 4 line, such as directory and deload. Also, like the Plus 4, it includes a machine language monitor built into ROM, which is very handy for troubleshooting or even writing small machine language programs. But here is something totally new. There's also this command, which brings up a built-in sprite editor, so you can design your own sprites, whether they be monochrome or multicolor mode, and then you can save the sprites to disk or use them with your BASIC programs.
And beyond just a better BASIC, they also finally addressed the issue with the slow disk drive speed.
Along with the 128 came a brand new disk drive designed specifically for it, known as the 1570. Now, it looked similar to the 1541, but when this disk drive was paired with the 128, it used something called burst mode, which gives it much greater speed. By comparison, the standard load routines on the 1541 was about 350 bytes per second. The 128 connected to one of the new drives was around 4,000 bytes per second, over 11 times faster, finally making it somewhat competitive to disk drive speeds of other computers. Also, the new disk drive was able to read MFM formats, so that the C128 CPM mode would be able to read native disks from computers like the Osborne and the K-Pro, as well as MS-DOS formatted disks. However, the 1570 was really just a stopgap and was only produced for a short time. The main issue is that it still used a single-sided drive mechanism, so that really limited its ability to read other disk formats since most of those were double-sided disks. The 1570 was discontinued as soon as the 1571 was ready, which was the drive they had originally envisioned as the companion to the C128. The 1571 had much more modern appearance, but also had double-sided drive mechanism, allowing it to store twice as much data on a disk without needing to flip it over. But it also made it possible to read most disks from other computers. Add to that, they finally put dip switches on the back of the drive so that it was easy to change the device number for systems with more than one disk drive. Soon after the 1571, Commodore released another disk drive called the 1581. And this drive finally allowed Commodore users to make use of the higher capacity 3.5-inch disks. And while this drive was backwards compatible with previous Commodore machines even as far back as the Vic II, when connected to a C128, it was also capable of the high-speed burst mode, along with the ability to read other disk formats.
The 128 was really designed to be a Swiss Army knife of computers. I mean, it really does a little bit of everything.
It was also advertised as being 3 computers in one, because it actually has 3 entirely different modes of operation. Obviously, you have your regular C128 native mode, which is how it boots up, and then you can type in Go64 at the basic prompt if you want to enter C64 mode. Alternatively, you can hold down the Commodore key on startup to achieve the same thing. Once in C64 mode, the computer really is like a C64 in just about every imaginable way, and that means there's no access to the extra 64K of RAM, no access to the Z80, no access to the 80-column chip or the RGBI monitor port, and no access to the enhanced BASIC commands. All of these extra keys on the keyboard will not work, including the number pad, and to top it off, the disk drive access is back to the usual slow C64 speeds, so quite literally, putting the computer into C64 mode makes it into a C64.
This was a very different approach to what other manufacturers like Apple, Atari, and IBM had been doing, where their new computers were better, but they were still more or less backwards compatible with the old computer without having to go into any sort of special mode.
If you wanted to run CPM software, you could insert the CPM Boot Disk that came with the computer before power up. It would auto-boot the CPM operating system. Speaking of, this is another new feature to the C128. It can auto-boot disks rather than having to type in a command after powering it on. One big problem that CPM always had was that while the software was standardized, the disk formats were not, so you could not take disks from an Osborne, for example, and expect them to read in a Kpro. However, Commodore took this into account, and the 1571 can read most all CPM formats. So I'll insert this Kpro Perfect Calc disk, which is a common spreadsheet program from the time. And when I try to list the directory, it'll pop up a message at the bottom recognizing it as a Kpro format. But even Kpro had more than one format, so I can use the arrow key to select Kpro 2, which is what this disk is. Press return, and voila, it just reads it. In fact, I'll go ahead and load up Perfect Calc, like so, and there it goes. It works perfectly, and so in theory, if you were using CPM at the office, you could take your work home with you and use it. Some common programs that could be used included things like MBasic, which was Microsoft's BASIC for CPM machines, as well as various spreadsheets and word processors. And you could even run the Infocom series of text adventures such as Zork and CPM Mode. However, CPM Mode didn't run very fast on the C128, so as an example, if you remember this game I showed a while back when I reviewed the Osborne called Ketchum, well, you see how fast it draws out the playfield here? And it actually runs fast enough that you can actually play the game. Now let's watch it run on the C128. Drawing out the playfield is painfully slow. And the game moves so slow that it's essentially unplayable. Now, this was probably not a big deal since games made up a very small portion of the CPM library, as most of it was business software and it ran at least acceptable speeds on the C128. And while CPM doesn't technically support any graphics or sound, it was possible to write custom C128 software in CPM mode that used the Z80 and took advantage of the C128's graphics and sound hardware, such as this game. However, as a result, this game will only run on a C128 and not any other CPM machines. And there was really no good reason to do this other than just as a proof of concept.
Why CPM? Did we think CPM was going to be used? We didn't know. But it wasn't our job to really know. It was our job to put as much stuff in there that might be used and let the users figure out what could be used. That's the way I looked at it. And I also wanted something that could use the 80 column day one. And you could. You plug in the CPM and there's WordStar and all these things already written for 80 column monitors.
In the end, CPM was rarely used on the C128, and there are numerous reasons for this.
For one, in order to use it, you really needed to have an 80 column monitor and a 1571 disk drive. And a lot of 128 users ended up with composite monitors or televisions and a cheaper 1541 disk drive. But
a bigger reason is simply due to a lack of available software.
A CPM was not sold in most computer stores, certainly not the type of stores you would buy a Commodore computer, and since the vast majority of CPM software was business software, most home users were simply not interested. But I think the biggest reason is that CPM arrived in 1974 and had already had its heyday in the late 1970s. Many computer magazines stated that CPM was dead as early as 1983. Certainly by the time the Commodore 128 arrived on the scene in 1985, CPM was virtually gone from the marketplace. The 128 also came in more than one variety. The next year, in 1986, the 128D was introduced to the USA. It had a more desktop-style appearance to it with a built-in 1571 disk drive, and the keyboard plugs in via a 25-pin connector on the side of the computer. Although it has a larger desktop footprint than the C128, it actually can end up saving space since the monitor can be sat on top of it. And although it's almost identical in function to the regular 128, it does have some newer ROM updates that fix a few bugs, and they included 64K of video RAM for the 80 column display, so there was no need to upgrade it.
So why was there a C128D? Or what's the story with that? Did this come later? I'll be asked. And the answer is no. There was always going to be two types of C128. Now I've got one of the original D plastic ones here. I have to say plastic because somebody came out with Black Diesel, which is the metal case one designed, I guess, in Germany or something after I'd gone. And you can tell it's got noisy video, and my keyboard snaps up underneath here, and it's got a handle. It's really cool. But we were always going to make a D. The production boards all had these two holes in the PC board for the D. Those are support posts. Well, if you look at the PC board very carefully, that defined how many traces I could get from this side of the board to this side of the board. So those two holes, oh man, they were a pain. That's literally why on the production board it says our IP and it lists our names and stuff, is we spent 3 days trying to get like the last 20 traces from one side of the board to the other side. And that's a whole story I could tell you at some other time. So the D was actually my favorite. It's got the disk drive built in. It didn't cost us any more to make. The plastic was shot. The tools were done. Everything. I leave Commodore and they sidecarred the D, and it wasn't until later that I think I heard that, I heard the rumor it didn't pass FCC. Wrong. I signed off on FCC myself. They both passed at the same time. The other thing was Commodore didn't have the cash to roll out 2 products at a time. Okay, that one I believe, and guess what? The LCD got axed at the same time, and that was never my intention. That by producing a Commodore 128, which is at best just a baby step after the 64, it is meant to fill in a year. We thought the 128 would sell for a year and a half, right? It was meant to go to the CES show and have something in the booth. I mean, that was the cycle, right? But the LCD machine was truly evolutionary. We actually were the only U.S. owners of a LCD plant, a glass plant, we called them back in the day, that we had gone out to buy and bought, and we could have broken into portable computers. The only competition were these horrible computers from Radio Shack, the gold and the blue screen. We'd have cleaned up, and it got axed also. By this time we had a new CEO named Marshall Smith, and he made the decision, no LCD machine. So if it were up to me, we should have done away with the 128 and done the LCD machine in its stead.
If you look at the 1987 Commodore Buyer's Guide, which is the official product guide produced by Commodore, in the 1987 version it clearly shows they were still selling the 64C along with the 128, and on the next page you'll see the 128D. However, looking at the 1988 revision, it shows all 3 computers on the front cover, but when you actually open it up, only the 64C and the 128D are shown, meaning that the flat 128 had already been discontinued.
So, how did the 128 do in the marketplace? Well, it was both a success and a failure. You see, it was a success because it sold for over 4 years and it sold over 4 million units, which is about 10 times more than its nearest competitor, the Apple IIc. So in that regard, it was a success. But where it was a failure was in its software library.
If you recall from the last episode, the Plus 4 suffered with its software library due to developers wanting to target the low-end C16, and this approach meant that software companies could get the largest market with a single product release. The Vic II also suffered from the same problem, with most of the software targeting the stock 3K system instead of taking advantage of RAM expanders. Well, the C128 was no exception, because at least 90% of users bought the Commodore machines with the intention to use it for games, and being that the 128 really didn't offer any improved sound or video performance, software developers felt it was easier just to code games for the C64. They knew that 128 users could simply switch to C64 mode to run the game, and that's why most every game after 1985 states on the box that it works with the C64 and 128. In reality, they were just regular C64 games. In fact, just a glance on Moby Games for the C128 specific games only shows 23 games. And the sad part is, over half these games are text adventures that just happen to use the 80-column display, but don't really offer any new gameplay aspect as compared to the C64 version. And none of these games are exclusive, meaning they are essentially just souped-up versions of C64 games. One game that I think definitely deserves a mention is Ultima V, Warriors of Destiny. And this one actually runs in native C128 mode, making use of faster disk drive access and the extra RAM so that it can load more of the map in at a time. But the biggest difference is that it has a musical track. The C64 version ended up having to cut out the music due to developers not being able to fit it in RAM. So if you want to play Ultima V on the Commodore, the 128 is definitely the computer to use. So in the end, CPM was probably used by fewer than 1% of 128 users, and only perhaps 10% of customers ever actually used any native 128 software, since most users were just looking to play games. However, it did have a few dozen productivity applications that supported it, specifically for the 80-column screen. One such killer application was no doubt DesTerm, as it allowed 128 users to call and connect to bulletin board systems that supported ANSI, which was mostly used by MS-DOS and Amiga users. But without a doubt, the most important one is GEOS 128. Now, while you could run GEOS on the 64, GEOS 128 took advantage of the 128's extra RAM and double the CPU speed and the higher resolution of the 80-column display. Running GEOS on the 128 put the C64 version to shame, and GEOS on the C64, even in half the resolution, could be hard to read on a composite monitor or television. But an RGBI monitor on the C128 delivered crisp graphics and text. There have also been a few impressive demos written for the C128, and the most interesting one being this one, which actually runs on the 80-column display, showing off some of the things that can be done with it.
And so, the 128 represents the end of the 8-bit era, and not just for Commodore. This was actually one of the last 8-bit machines ever produced, because by 1989, most of the manufacturers had already started producing 16 and even 32-bit machines. However, this is not the end of the Commodore series though, because in the next episode we need to tackle the Amiga. So be sure to stick around for that episode, and thanks for watching.